In this video, I'd like to talk about the math question of the day for Friday, May 12th, 2023. And with this problem, we need to find the rectangular coordinates with the given polar coordinates 6, 120 degrees. And remember that rectangular coordinates, those are just the normal x, y coordinates, but polar coordinates measure the distance the point is from the origin and the angle that the point makes relative to the positive x-axis. So we can write that as r comma theta. Now, you will typically learn polar coordinates in a pre-calculus class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And it'll be best to start with sketching the relationship between rectangular and polar coordinates. We can draw in the normal xy plane, and let's say we have some coordinate point, which we can put maybe right there. We can say this is the x value and this is the y value. We can call this at x comma y. But polar coordinates measure the distance from the origin. So we can draw a line going from the origin to our point, and we call that r. And they also measure the angle, which we can call theta, relative to the positive x-axis. So this right here will be theta. And with this drawing, we can create a right triangle. If we drop a perpendicular line to this x-axis, and we can also draw in a line parallel to the x-axis, going to that x value and starting at the origin, then we have a right triangle where this vertical part, this is y, and the horizontal part, that is x. And from here, we can use trigonometry to set up a relationship between the x and y value and the r and theta value. And we can also use the Pythagorean theorem. Since we have a right triangle, we know that when we square the legs and add them together, that they're equal to the hypotenuse squared. We'd say that x squared plus y squared is equal to that radius r squared, or that distance from the origin. And again, using trigonometry, we can relate x and y to theta and r. Though if we want to use trigonometry, we will need our right triangle trigonometric definitions. We can use SOHCAHTOA for that. And let's say that we want to define the sine function. We can say that the sine of our angle theta is equal to the opposite side divided by the hypotenuse. We know that the opposite is y, and we know that our hypotenuse is r. And from here, we can rewrite this in terms of y. We can multiply both sides of this equation by y, so that we get y is r multiplied by the sine of theta. And likewise, we can do the same for the cosine. We can say that the cosine of our angle theta is equal to the adjacent side, which is x, divided by that hypotenuse, which we know is r. And again, if we want to solve for x, we can just multiply each side by r, so that we get x is equal to r multiplied by the cosine of theta. So we know how to relate x and y to r and theta now. And if we want, we can even use tangent. We will have that the tangent of the angle theta is equal to the opposite side, which is y, divided by the adjacent side, which is x. So using all the trig definitions, the basic trig definitions, we have these nice relationships, and each of these can be used at different points. For instance, with this tangent function, we can typically take an inverse tangent of each side of this, so that the inverse tangent of y over x is just equal to theta. So that we can solve this explicitly for theta, we can solve this equation explicitly for r, and then we have already solved these equations explicitly for x and y. And they will all be useful in very different scenarios, but we are told that r is 6 and our angle theta is 120 degrees. So let's make a little bit of room. We can keep our relationships in the picture, but we're told that r is 6 and theta is 120 degrees. And for this problem, we just need to know the x and y coordinates. So we can use these equations here, that x is r times by the cosine of theta and y is r times by the sine of theta. So let's just plug in our values here. We'll have that x is r, which is 6, multiplied by the cosine of 120 degrees. And we can simplify this. You could use a calculator, or you can use the unit circle. We know that a 120 degree angle will be right here. And remember that at any point on the unit circle where our angle is theta, the x and y coordinates on this unit circle, the x coordinate is the cosine of the angle and the y coordinate is the sine of the angle. So at this point over here, we're really looking for the x value. This is the xy coordinate plane. And in reality, we will end up with a 30, 60, 90 triangle where the hypotenuse is 1. We can do a little bit of arithmetic with that. Since this big angle is 120, this angle right here is 60. So let me quickly sketch that picture. We have a 60-degree angle, meaning this is 30, and the hypotenuse is 1. We're looking for this coordinate right here, but in a 30, 60, 90 triangle, the smallest side length opposite the 30-degree angle is half of the big side length. So that would be 1/2. And this just comes from the properties of these special right triangles, these 30, 60, 90 right triangles. And if we wanted, we also have this side length here, which is the square root of 3 multiplied by the small side. So this would be root 3 over 2, which we'll use when we do the sine of 120. But the usefulness of the unit circle is that we can recognize that x values on the left half of the coordinate plane are negative. So this cosine of 120 degrees is the opposite of this value right here. It would be -1/2. So that x is 6 multiplied by -1/2, or x is -3. And we'll follow a very similar logic for y. Let's plug in what we know about that. Y is the radius 6 multiplied by the sine of the angle, which is 120 degrees. And the sine values are positive in the top half of the coordinate plane. And the sine values are the y value on the unit circle. And we know that the vertical component, the y value, is this root 3 over 2. So we can plug that in. We have 6 multiplied by root 3 over 2, which would be 3 times by the square root of 3. So we found x and y. We now know that x is -3 and y is 3 multiplied by the square root of 3. And we can check this in several different ways. We can actually use our other two equations here. If we plug in x and square it and then add that to y squared, we will get 6 squared, or 36. And likewise, if we plug in y is 3 root 3 and x is -3 into this formula here, and we take the inverse tangent of that, we will get our angle, though I should mention it's actually a little bit more complicated with this formula. This formula is only valid between angles of -90 and 90 degrees. So we would have to actually shift our angle by 180 degrees. We would have to add that to the angle we find by plugging in these values. But if we do add 180, we will get back 120. And likewise for this equation, we will get back that our radius has to be 6. So there are several different ways to check this, but you can visually confirm this by just plotting this. We know it's at a 120 degree angle, which would be along this, and we know the radius must be 6, or this distance from the origin must be 6. So having an x value that's negative, -3 does make sense, and having a y value of 3 root 3 will also make sense because we can use that Pythagorean theorem there.